So, Chapter 9, Lesson 5 is polygons on the coordinate plane. So the first thing we want to do here on the warm-up was to graph points on a coordinate plane to draw a map of an outdoor stadium. So to complete the table, first we want to complete this table. First we want to graph, then complete the table to identify the shape of each figure. So when we graph 2.2, 2, 9, 6, 9, 6, 6, and all the rest of them, this is the graph. This is what your graph should look like. Okay? So if I look at the stage here, what shape is that? We have 1, 2, 3, 4, 5, 6 sides, so that is a hexagon. Very good. That is a hexagon. Then the bleachers, of course, that is a rectangle. And the concession stand is equal on all sides, so that is a square. Very good. Now we want to find the dimensions of the bleachers. Okay, so the length, if we're looking at it like this, because bleachers is written like that, the length would be here and the height would be here. You see that? So the length is 1, 2, 3, 4 units. And the height is 1, 2 units. You ever see that? Okay, so that's the length and the height. So the length of the line from point 2, 6, here's 2, 6, 2, 6 is right here, to point 2, 9, 2, 9 is right there, is 3 units long. 1, 2, 3. So if I have 2, 6 and 2, 9, how can I get that 3 units? 2, 6 and 2, 9. What do you notice? What can you do here? Yes. Well, you could just subtract the 6 and the 9, right? So that is how you can get the distance between those 2 points, is to subtract. Finding the perimeter. You can use the coordinates of a figure to find its dimensions by finding the distance between the 2 points. Okay? To find the distance between 2 points with the same x coordinates, you want to subtract their y coordinates. Okay? So we see that? To find the distance between the 2 points, with the same y coordinates, you're going to subtract their x coordinates. So if I'm looking at example 1, it says a rectangle has these vertices. We want to use the coordinates to find the length of each side. And then we're going to find the perimeter. Okay? So if I'm looking at point A, AB, from point A to point B, and we want to find, there's A, there's B. So A is 2.8. B is 7.8. Okay? They have the same y values. Does everybody see that? So that means that we need to subtract their x values. So 7 minus 2 is 5 units. Is everybody clear with that? And because this is a rectangle, do I have to show the work for line segment CD? No, because opposite sides are congruent, right? So now we can find the distance between point B and point C. So here, B is 7.8, and C is 7.5. So they have the same x values, so we're going to subtract the y values. So 8 minus 5 is 3, and that's how we get our dimensions. Is everybody clear? So now to find the perimeter, we just add all the sides together. Okay? So 5 plus 5 plus 3 plus 3, that gives me 16 units. Got it? Example 2 is the same the same as example 1, except they just haven't drawn a picture. Okay? So here, you're going to subtract the y coordinates for AB because they have the same x coordinates. And then for the line segment AD, we're going to subtract, there's A and there's D. They have the same y value, so we're going to subtract the x coordinates. Okay? Now, I do want you to keep in mind the difference between the perimeter and the area. Okay? The perimeter is the distance around the figure, and the area is the number of units used to fill a figure. Okay? All right, so this is what I want you to write down. We want to use the coordinates to find the length of each side. Then we're going to find the perimeter of the rectangle. Okay? So we have E, F, G, and H. Okay? E, F, G, H. So we want to, let's just imagine what this looks like. So E is at 3, 6, 3, 6. F is at 3, 8. G is at 7, 8. And H is at 7, 6. So we have a rectangle, right? Is everybody with me? So this is E. No, that's not E. E is 3, 6, right? So this is E. And then 3, 8 is F up here. G is over here, 7, 8. And H is down here, 7, 6. So we have a rectangle. So if I'm going to find, let's find one of our dimensions. Okay? So let's find F to G. Okay? So F to G, I've got point F right there. And I've got point G right there. Is everybody with me? So this, is that going to be the length or the width? That's going to be the length, right? So the length we're going to find by subtracting, because we have the same y value, we're going to subtract the x values. So 7 minus 3 is equal to 4 units, right? Good. So now let's do F comma E. I mean F to E. So here we have point F and point E. And of course that is going to be what? The length or the width? Of course that's going to be the width, because that one over there is the length, right? Okay. So to find the width, we're going to subtract the y values. So 8 minus 6 is equal to 2 units. 8 minus 6, 2 units. Is everybody with me? All right. So now, to find the perimeter, we're going to add up all of the sides. So this up here is 4, down here is 4, this is 2, this is 2. The formula for the perimeter, is everybody ready? So the formula for the perimeter is 2 times the length plus 2 times the width. So now you have your formula written down. Now you're going to substitute. So we have 2 times the length, which is 4, plus 2 times the width, which is 2. So we've got 8 plus 4, which is equal to 12 units. Is it just units or units squared or units cubed or what? It's the distance around the figure, so it's just units. Now, and that's all there is to it. All right, for example B, once again, I would like to visualize the coordinate grid and look at what kind of shape we have here. And then we have 8, comma 9 would be up here with the J. So that's K. And then we have 8, comma 4 right there. So this would be the L, and this we would again have a rectangle. Is everybody clear? All right. So now we want to find, let's find the length. Okay, we want to find the length. So if I'm looking for the length, this is JK. Which coordinate is the same, the X or the Y? If I'm looking at the horizontal, it's going to be the Y, right? So we want to choose 2 points that have the same Y value. So that would be, there's J and K, right? They have the same Y value. And now, to find the length, we can subtract their X values. So 8 minus 1 is equal to 7 units. Very good. All right, so now we want to find the width, right? So let's do KL. If we have KL, they have the same X value. Very good. So there's K and there's L. And you can see, bless you, they have the same X value. So since they have the same X value, in order to find our width, we subtract their Y values. Very good. So 9 minus 4 is equal to 5 units. Is everybody clear? All right. So now we can find our perimeter by using our formula. So now there's our formula. Now we're going to substitute in for the length and the width. So 2 times the length is, that's 2 times 7, plus 2 times the width, which is 5. 2 times 5. So we've got 14 plus 10, and that gives us, very good, 24 units. On this example, example 3, it says each grid square on a zoo map has a length of 200 feet. So each one of those lengths of the square is equal to 200. So it's 200, 400, 600, 800, 1,000, and so forth. Does that make sense? Okay? Now, you need to make sure you remember this. When X coordinates are the same, we subtract the Y coordinates to find the distance between them. When Y coordinates are the same, we subtract the X coordinates to find the distance between them. All right, so in order for us to find the distance between the entrance and the monkeys here, okay, which values are the same? The X value is the same, so we're subtracting the Y values. So 10 minus 0 gives me 10. Does everybody see how we got that? Then here from the monkeys to the gorillas, which values are the same, the X's or the Y's? The Y's are the same, so we're going to subtract the X's. So 7 minus 0 is 7, so that's 7 units, right? Down here, going from the gorillas to the elephants, okay, gorillas to the elephants, the X value is the same, so we're going to subtract the Y values. So 10 minus 7 is 3. Is everybody clear how we're getting those numbers? So once you get all of the measures of each one of those sides, then you just add them all together and you get 42 units. So the distance around the zoo on the grid is 42 units. But the distance around the zoo in real life, what do I have to do to this units? I need to multiply times 200, right? So 42 times 200 gives me 8,400 feet. So the total distance around the entire zoo is 8,400 feet. The coordinates of the vertices of a garden are as follows. If each unit represents 12 inches, find the perimeter in inches of the garden. So here we want to find the length and the width and then find the perimeter, right? We're going to use the same formula as we did before. So if I'm looking for, and I'm not even going to draw the picture, we're just going to try to visualize it. If I'm looking for the horizontal length, which values are the same, the x's or the y's?
The Y.
The y value is the same, right? So that means, let's see, which one of these have the same y value? This one?
Yeah.
And this one. Very good. So those are the same y values, and we are going to subtract the x values to get the length. So the length is equal to 8 minus 0. Of course, we're going to show our work always. 8 units, right? Eight units. Now, we want the up and down, the vertical. So just watch my pen. If the pen is going up and down, which values are the same? The x values are the same. Very good. So which one of these have the same x values? 0, comma 1 and 0, comma 4, or 8, comma 4. Let's just do 8, comma 4 and 8, comma 1. Okay? So the x values are the same, and this is going to give us the width. Right? So 4 minus 1 is equal to 3 units. All right, so you're going to write your formula for the perimeter of a rectangle, and this is perimeter is equal to 2 times the length plus 2 times the width. And now we will substitute. So 2 times the length, which is 8, plus 2 times the width, which is 3. And now we simplify. So that's 16 plus 6, right? 16 plus 6, 22. So 22 units. So my garden is 22 units around, right? But how many inches is it? What do I have to do to that 22 inches? Right. So, because each unit represents 12 inches, we need to take that 22 units and multiply that times 12. Okay. So, the distance around the garden is 264, oh, not units, it's inches. Very good. So 264 inches. Inches squared? No, because we're not finding the area. Very good. So just inches. So now we want to find the area. Okay, if you can find the area of a figure that has been drawn on grid paper or graphed on the coordinate plane. So here's how we do it with the grid paper, and we've already done this before, right? So we want to find the area of the figure in square units. The figure can be separated into a rectangle and a trapezoid. So first we want to find the area of the rectangle, and when you do that, you're going to write your formula, and we don't like to use the x for the multiplication, right? We want to use the dot, right? So length times width, or just put them together. And then we do our substitution. So this is 5, 1, 2, 3, 4, 5, times 2, 1, 2. That gives us 10. So formula, substitution, answer. They should put the answer down here. Equals 10. Okay? 10 units. Is everyone with me? Yep. All right. Then the formula for the area of a trapezoid is 1/2 times the height times the sum of the bases. So when we do that, we substitute in simplify before we multiply, and the area of a trapezoid is 7. So when we add them together, 10 plus 7, that gives us 17 units squared. Is everybody clear? All right, so let's do this one together. So this, what shape is that?
A rhombus.
Well, not a rhombus because it doesn't have equal sides. It's just a parallelogram, right? So the formula for the area of a parallelogram is base times height. So now we can substitute in by counting our squares here on the grid. So that's 1, 2, 3 for the base. And for the height, that's 1, 2. Very good. That's 2 for the height. So 3 times 2 is 6. And because we're talking about area, it's units squared. Very good. Now, we can also graph on a coordinate grid to find our dimensions. So here, a figure has the vertices A, B, and C. And we want to graph the figure and classify it, then find the area. Okay? So, once we plot the points, you'll see that that is a triangle. The triangle formula is 1/2 base times height. So, once we write the formula, then we substitute what we know. So we have 1/2 times the base. Now, it can be either one of these, right? It can be either one because they both drop down to a right angle. So base is 1, 2, 3, and then the height is 1, 2, 3. You got it? So then we simplify to get 4.5, and it's square units because we're talking about area. Simple? All right, so let's do this one together. All right, so the first thing we're going to do is we are going to graph the figure. So we have A at 3, 3. There's A. We have B at 3, 6. We have C at 5, 6. And D at 8, 3. What is the shape? Trapezoid. Very good. So this is a trapezoid. So the formula for the area of a trapezoid, area is equal to 1/2 times the height times the sum of the bases. Very good. Base 1 and base 2. So now we wrote our formula. Now we can substitute. So we've got 1/2 times the height, which is 1, 2, 3. There's the height, times 3. Times the sum of the bases. So this base up here is 1, 2. And this base down here is 1, 2, 3, 4, 5. So this is going to be 2 plus 5. And now we can simplify. So we've got 1/2 times 3 times 7. So this is half of 21, which is equal to 10 and 1/2. Very good. So you can put 10.5. What do I put for my label?
Units squared.
Units squared. Units squared.